Hi and welcome to this tutorial on Houdini L systems. In this video, I'll go over the process that I use to create the simple plant for the magic market scene. L systems might seem scary at first. I mean, what do all these letters and symbols mean? But once you understand that all these letters and symbols are basically just a set of simple directions, all that fear falls away and you can start creating some very interesting systems. Let's begin with the basics. The most used symbol will be F. Think of F as standing for forward. So we place an F and move forward a set distance. Cool, now let's move forward again, so we place another F. Simple enough, so traveling in a straight line is kind of boring. Let's turn right. To do this, we place a plus, which means turn right. Remember, these symbols have nothing to do with their usual meaning. Plus has nothing to do with addition. So we've stated that our next step is to turn right. Next, we want to move forward again, so we place another F. Now let's turn left. To turn left, we use the symbol minus. Remember, it's just step-by-step directions. So we turn left from our current position. So if you're using L systems, chances are you're going to want to create something that has branching, such as a tree. Branching in L systems is done with square brackets. The open brackets represents the start of a branch, and closed represents the end of a branch. The brackets basically contain extra information, separate from the current path we are on. So let's start again. We'll go forward twice with FF. Now we're going to turn right. But this time it is going to branch off from the current path. To do this, we drop down a square bracket. This is the start of a branch, followed by a plus F, and close brackets. This looks the same as before, but see what happens if we add another F after the brackets. The path continues from before the square brackets. Now if we wanted, we could keep traveling up our main path by adding more instructions after the square bracket. Or we could add more information to our branch by adding more instructions within the square brackets. I could continue going over the basics, but let's create something a little bit more interesting and learn as we go. Alright, let's get started by dropping down a L system. Let's dive inside, and here we'll find our L system node. You can see at the moment it's given us this default tree. To change that, let's go into the Rules tab. As you can see here, this contains all the rules to create this tree. Since we don't want it, let's remove the rules. Like that. And let's type what we created earlier. F, square brackets, plus FF, minus F, outside of the square brackets, FF, and press enter. As we can see here, this isn't exactly what we created earlier. We're missing those right angles. To change that, we can go up here to the Values tab. This contains all the global values for our L system. The one we're interested in is this angle. At the moment it's at 28. I can adjust it with the slider. I can set this to 90 degrees, and that fixes the problem. Another way of doing it is to go back to our rules, create an explicit value. So for our turn right instruction with the plus sign, let's drop down some brackets and put in the value of 90. Let's do the same for our turn left instruction. And there we go. Let's clear this premise and type FF, which gives us forward, forward. Now let's drop in an A. What is A? Well, currently A is nothing, so let's give it a value. In our first rule, let's type in A equals, and this is where we'll give A some instructions. Let's say F plus F square brackets plus F. So there we go. As you can see, we've got FFA, which is forward, forward, and then we bring in A, which is F plus F square brackets plus F. This is cool because we can now substitute rules into rules, giving us the ability to create very complex else systems. Let's add an A to the end of our rule, like this. So basically what this is doing is calling A within A. So once A is run, we call A again. Let's press enter. As you can see, we have this. Now this is controlled with generations. You can find generations within the geometry tab up here. At the moment it's set to 7. We can push it up to 15, and we get something like this. Let's bring it back down to 7. As you can see, if I bring the slider down, it shrinks, bring it up again, it grows. This generation is controlling how many times we have the rule substitution. This is a powerful concept within else systems, generations, but we'll get back to it later. So let's get into one of the plants I created for the Magic Market scene. It has a nice simple structure that will allow us to try a few techniques. First things first, let's bring up some reference. Looking at this image, we can try to break down its structure. We can see that it's broken up into segments. At the end of each segment, it branches out into 3, which is made up of 2 leaves and 1 flower. So let's get started with this plant. Let's delete what we've created. Let's drop down A, enter. A doesn't exist yet, so let's create it. A equals F, and we want it to branch off, so square brackets, F, enter. There we go. At the moment it looks like a single line, but if we activate display points, we'll see that we've got 2 segments. The problem is that it's currently pointing straight up. We want it to angle down a little bit. So to do that, let's drop in this symbol, and this symbol means angle down. Let's press enter. You can see we've got it angled down. Cool. So let's create our other 2 branches. We'll just do exactly what we did with the first one. Okay, we've got 3 branches here, but we can't see it because they're currently sitting on top of each other. To fix this, we want to roll each branch. So to roll it, let's put in the symbol, put it between that branch and that branch, and now we've got a separation. But we want an equal angle between them. So remember, we can set an explicit angle or an explicit value by putting bracket after the symbol and put in the value we want, 120. There it is. Currently we have the first segment of our plant, but we want multiple segments. To do this, we just call A back into our rule at the end. Here we go. Now remember, this is controlled with the generation amount. So if I bring this down, push it up. As you can see, when I'm moving it like this, we get a gradual growth. I prefer to have it in more of a step-in manner. So to do that, I'm going to disable continuous angles, continuous length, and continuous width. Now what I get is this. I find this a lot easier to work with when you're trying to get the look of a plant down. The next thing I notice from our reference image is that the stem for the flower is a lot longer than the stem for the leaves. Now I can adjust the length of the individual stems, but I prefer to add some resolution. So to add resolution, I'm just going to add more segments. To do that, I'll just add another 2 Fs in our first branch. And that gives us this. As you can see, I now have 3 segments for this branch. Now obviously this is too long, we need to adjust the length. To do that, I can go in and within brackets after the F, give it a length of, let's say, 0.02. That adjusts the first segment, so we have to do it for the next 2 as well. There we go, we can see we've adjusted each one. Now, this works, but it's kind of tedious and it's getting a little bit messy. So let's do rule substitution for this. Let's create a new rule, call it B. Let's just copy and paste what we've done here. So B equals what we have over here. And now we can remove all of this. Just leave in that down angle symbol and drop down B. So now we're doing a rule substitution, we get the exact same result. But what I'm going to do for this is remove all of this and just keep that single line. And then instead of calling B in once here, I'm going to call it in 3 times. This will make sense further down the road. So currently this is too short. So let's adjust the length, make it slightly longer. And let's add another segment. Let's put another B in there. Cool. So let's do the same thing for the other 2. The stems that will have the leaves on them. They all share the same rule. So let's create another rule for them and call it C. C equals, let's give it a length of 0.01. And let's remove this F and put our C in 3 times. And then the same for this. Cool. So now we have our long stem that is controlled with the B rule and the 2 shorter ones which are controlled with C. So the next thing we want to do is add some shape to the plant. At the moment, all the stems are straight lines. So let's add a little curvature to it. We can see from our reference image that the stems which have the flowers on the end bend upwards, while the small stems with the leaves on the end bend downwards. So let's do the one for the flower stems first. To do that, we're going to use the symbol for an upward bend. And we're going to override the global value by putting a value of 10 degrees in brackets. As you can see, it now bends upwards. Now let's sort out the smaller stems for the leaves. We'll use the symbol for down angle. Once again, override the global value and give it a value of 10 degrees. There we go. Now, instead of viewing this as lines and points, let's view it as geometry. Firstly, I'm going to disable the display points. I'm going to go over to Geometry tab and change the type from skeleton to tube. At the moment, it's a bit of a mess, so let's fix that up by going into the Tube tab and changing these values of rows and columns. Let's push it up so that we have more resolution. There we go. Now we can adjust the thickness with the slide over here. But for the moment, I'm going to keep it at its default. Now let's have our plant taper on the ends of each branches, but also taper overall with each generation. If we hover over the thickness scale we'll see this pops up. It says how much the exclamation operation will affect the thickness. Exclamation mark is the symbol used to control the thickness scale. So if we go back to our rules and put the exclamation down, you can see now that there's a slight taper as it goes towards the end. Let's do the same for our C rule. So if we go back to the tube, this affects the thickness scale. Let's drop this down to 0.8. And let's drop the overall thickness to 0.07. So at the moment, each branch has a taper. What I want to tackle next is to have an overall taper for the plant. This needs to be controlled with the generations. So to do that, let's go back to our rule. And for our overall plant, put the exclamation mark down. Now we can see the plant starts, and as it goes up, tapers off. What our plant needs now is a little bit of variation. To do this, let's add in this symbol, followed by brackets, and a value of 20. What this means is we'll get a random value for the angle to a maximum of the value we've put in brackets, which in this case is 20 degrees. So we'll get a random value up to 20 degrees. Let's do the same thing for this one. And choose a value of 10. Now let's add a little bit of variation to the main stem. Let's go to this rule here. Now that gives the variation I'm looking for, but it's also given me a random angle right from the base, which makes the entire plant lean over. I want the plant to come out of the ground straight and then start bending. So to overcome this, I'll just add another segment at the base. In the premise, I will put F. And now our first segment is straight. It's a little bit long, so I want to adjust the length. To do that, drop brackets after the F and give it a value. And that's better. Now that we have the main shape of our plant done, let's add the leaves, flowers, and flower buds. To do this, I'm going to call in some geometry I created with an object merge. Let's have a look at these geometries on their own. Here's the leaf. Here's the flower. And here's the flower bud. So let's plug in each one of these into our first three inputs. If we hover over the input, we'll see it says leaf J input, leaf K input, and leaf M input. J, K, and M can then be used within our rules to reference these geometries. So let's go back to our L system. Let's add our flower first. Our flower needs to be put on to the end of the long stem, which is at the end of these 4 Bs. Remember, our flower is plugged into our second input, K. So all I have to do is drop a K over here, press enter. Now if we have a look, we can see our flowers on the end. Let's do the leaves next. Our leaves are connected into the first input, which is J. So let's put a J at the end of this. And at the end of our second stem, now we have some leaves. As you can see, our leaves and flowers are too small. So let's scale them up. We can use a transform node. Let's do the leaves first. Looking at the plant, the next thing I see that needs some changing are the size of the leaves and the flowers. At the moment, the leaves and the flowers are the same size from the base of the plant up to the tip. What I want is for the size to decrease as we go up the plant. To do this, I will drop in the symbol over here, and that will just multiply each generation by this value here. So I can shrink it down if I want, but I'll leave it at the default value of 0.9. The next problem now is that our stem for our flower is way too long. So let's change the length of that by coming in here and making it smaller. Now let's change the length and the thickness of the leaf stems. Let's change the length first. And then to change the thickness, all I have to do is put a comma and give this a value. I think something like that will be okay. Let's add some more generations to this. Let's make it 7. If we look at our reference image again, you can see that we want the flower buds to appear, but only at the top of the plant. So to do this, let's create another rule. So let's go over the rule we just typed out. We have the length scaling down with each generation. We also have the thickness being scaled down with each generation. We now have a segment with a length of 0.02. We then have our first branch, which is a downward angle, followed by B, this rule over here, being substituted into it 3 times, and an M, which is our third input of our L system. We then have it rolling counterclockwise by 120 degrees, and then we just repeat that another 2 times. And then I ended up removing the A at the end. To use this new rule, let's put it in the premise after A. The reason for this is I only want the flower buds to appear at the end of the plant and not to be used in each generation. As you can see here, we now have our 3 stems with flower buds. Now, if I would like to change the angle of these stems, I could always just go in here and give it a value. So let's say 20. Now I'd have to do it for this one as well. And this one over here. Now this works, but if I wasn't happy with that value, I'd have to go in and change each value. There is, however, a better way of doing this. If you come over to the Values tab, you'll see that we have this variable B, variable C, variable D. We can use this in place of a value. So I'm going to use variable B in there, and over here. Now, if I want to make any changes to it, I just have to come over here and adjust it, and we'll adjust all 3 for me. So we have B, C, and D that we can make use of, but we can also create our own by coming over here and adding one. And we can give it any name we'd like. So if we wanted to, we could call it flower bud, for instance. And then within our rule, we'll just call it. So instead of B, we'd have flower bud. Now, at the moment, this doesn't look too bad. But I'm only using a single type of geometry for the leaves. I'd like to add some randomization and variance to this by adding another leaf geometry. But as you can see, all our inputs for geometry are used. Fortunately, there is a way to add more geometry. First of all, let's bring in our second leaf geometry. We'll now drop a switch node and connect our two leaves into it. We're going to make use of stamping. To do this, type in stamp, open brackets, and the location of our L system. And also a default value. Now, let's go back to our rules. And after the J, which is our first input, we'll just add this. This one at the end controls which input we're using in our switch node. The first input is 0, the second 1. Let's add it to the other J as well. We'll make this one 0. As you can see, we have a combination of our original leaf plus our second one. Now, this isn't exactly random. Currently, we have a leaf 1 and leaf 2, leaf 1 and leaf 2, leaf 1 and leaf 2, and this happens with each generation. So to give it a little bit of randomization, let's first duplicate this rule, just copy it and paste it here. And I'm going to change these to both be from input 0 on the switch node, and this first one over here will both be from input 1. We now have identical rules, with the only difference being the switch input values. This being 1, 1, this being 0, 0. To give this a bit of randomization, we're going to use probability. To do this, all we have to do is add this at the end of our rule. 0.5 after a colon. This is our probability, 50%. So there's a 50% chance that we will use this rule. Otherwise, we'll use this one over here. Next up, I'll go into the Geometry tab and mess with this random scale slider a little bit. This will just give us slight variations in our scale. We can also move the random seed value, and this will give us some variations of our plant. We can now check these boxes if we'd like. And apply color. So this plant was one of the simpler plants used in the Magic Market scene. It shows off the basics of L systems. Hopefully this has given you the building blocks for you to create your own more complex L systems. I hope you found this helpful, and until next time, goodbye.